Good afternoon, everyone, and thank you for joining our webinar with Hager on the 18th edition Amendment 2, Understanding the Changes. We're just gonna give it a few minutes to let more people join, then we will start. Thank you. Perfect. For those who just joined, welcome to our webinar with Hager on the 18th Amendment to Understand the Changes. My name is Wiem Melki. I'm the Marketing Coordinator at Rexel. Our guest speaker today from Hager is Ian Wassell, who will be introducing himself shortly. Please note that this is a recorded webinar and will be available to watch on demand on our Rexel website. The webinar is CPD accredited and certificates will be sent directly from CPD to you. This can take up to 5 weeks. If you have any questions throughout the webinar, please feel free to pop them in the Q&A box and we will answer them at the very end. Now passing over to Ian from Hager.
Hello everybody, welcome to our webinar. Today we're going to look and discuss the changes around the 18th edition Amendment 2. We're going to pick the important changes and where they will actually mean something to you. Hopefully this will give you a little bit of knowledge around those changes as these changes are now implemented. So let's move forward with a little bit of history around the wiring regulations first so we can see where they come from. So first of all, we've got an international standard. So it's an IEC 60364. Now this is what the whole world tries to work to. Now unfortunately the standards that are in this 60364 don't always work for everything that we do. So we take some of these regulations and we filter them down. First of all, we filter them down to what we call CENILEC, which is a European harmonized standard. So from there, okay, still we get some regulations that don't work for us, okay, in the UK. So what we do again is we push them then into our own BS 7671. Now there's an interesting feature around this because there's a lot of people that look at these regulations from the international standard, from the European standard, that help get these regulations ready for us. Now these people, okay, are a UK joint IET and BS technical committee, a JPEL group. Okay, now this JPEL group is made up of a lot of people. So when people say, oh, you know, a certain group pushes the regulations through, that's not quite the case. Okay, the regulations get voted on by a wide group of people. Now here's some of these people. So BEMA, they represent manufacturers. Searchshaw, NAPI, ECA, okay, they're your governing bodies, okay, that work for you. The Health and Safety Executive, City and Guilds, all these people have a big say. But most importantly, you also have a say. So when we produce these regulations, okay, and they are drafted for public comment, you get a chance to say what you think about the amendments that they're looking at introducing. At that point, if you make a comment, okay, that comment has to be looked at around a table. It can't be dismissed, okay? So no matter how stupid you think your comment may be, that comment will get looked at around a table. If enough opposition to a regulation is given, that regulation can then get changed, okay? It may even get thrown out. So it's your one opportunity to have a say of what goes into these regulations and these amendments. So it's worth doing that. Now, we've got BS 7671 2018, okay? We've had that for 2 years now, okay? Very quickly, we had Amendment 1, okay? Amendment 1 was around car charging, okay? They realized quite quickly we needed to put some extra regulations in there around car charging. It was quite difficult to connect vehicle chargers to domestic properties. So we had to make some sort of quick amendments there. We've now moved on to Amendment 2, okay? So that's where we are at the minute. The brown book, I'm sure you've all gone out and bought that brown book because for us, that is our Bible. So it was published on the 28th of March. That gave you all an opportunity to go and look at these regulations. Now, once you've looked at these regulations, you get a period of time where you can either say, right, I'm going to use these regulations straight away, or like most people, I will wait till it gets implemented, okay? So it comes with its own designation, okay? So it's BS 7671, 2018, Amendment 2, 2022, and that's the current regulation. Now, Amendment 1 was withdrawn, okay, from use on the 27th of September. Now, that's an interesting word, withdrawn. We've never had that before. We've always had past amendments running alongside the new amendment. Now, if we'd got an old design, we could still work to a past amendment, but it's been a loophole for a lot of years. So they've decided now we'll take that loophole away. So as of the 28th of September, okay, we have to use Amendment 2. Now, what does this mean for us? Okay, so if we've started an electrical installation before the 27th of September, what does that mean for us? We would started that to Amendment 1. We are allowed to complete that installation to Amendment 1, as long as we've got everybody's agreement on that. So possibly building control, possibly the building owner, the main contractor. We've all got to sit down and say, yes, we are happy, we've started that, and we will complete it to Amendment 1. Anything started after the 28th of September must be to Amendment 2. So existing installations. So we all look at existing installations, we do EICRs, and as long as there's nothing wrong with those existing installations, we do not have to apply these regs retrospectively, okay? So we can leave them to run under a past amendment. Any new additions though, okay, must be to Amendment 2. So we're going to look at definitions now. We're going to start looking at the regulations. Now at the front of the regs book, okay, we've got definitions section. It's worth looking at this because we've all used the word recommendation. Now they've put some weight behind that word recommendation now, okay? And for the first time in the regs book, they've published a table which puts some meanings to certain words. So where we see the word shall, it is a requirement. It's something we must do. Where we see the word recommendation, they're saying it's something we should do. So let me just explain that a little bit more. If we've got two options to do and meet a regulation, maybe negate fire in a property, okay? There's a few ways of doing that, but if one is recommended, that is the one we should use, okay? So they're putting a little bit of weight behind these words now, okay? It doesn't mean to say that because it's a should, we have to do it. It's still a recommendation, but that recommendation carries a bit more weight. So we're going to jump into the regs now, and the first part we're going to jump into is part 4, RCD protection of socket outlets. So the regulation now says that in AC systems, additional protection by means of an RCD with a rated residual operating current not exceeding 30 milliamps shall be provided for. And it gives us 3 areas. Okay, so socket outlets, okay, where they are liable to be used by persons of capability. And it gives us these numbers and letters, BA1, BA3. BA1 is an ordinary person, okay? BA3 is a disabled person. BA2 is a child. So we've got these category of people. If they're going to use a socket outlet, it must be protected by an RCD. Then we've got number 2, which pretty much covers every other kind of socket we might have. Socket outlets, okay, in other locations. Then we get number 3, mobile equipment, rated current not exceeding 32 amps for use outdoors. Okay, so that's pretty much got socket outlets sewn up. Okay, so what if we've got an installation, maybe a server room, where we don't want RCD protection on our socket outlets? We used to be able to label up a socket that said fridge freezer only, okay? We didn't need to protect it. that went with the 18th edition Amendment 1. Okay. Then we got the ability to use a risk assessment to risk assess out that need for an RCD. So that could be used in certain situations. So what do we do now? Okay, well, we still got the ability, okay, to have a risk assessment, but we can only apply that risk assessment to our indent 2 of the regulation. So if it's going to be used by an ordinary person, it's got to have socket RCD protection. Sockets that aren't being used by an ordinary person and are being used indoors, we can apply a risk assessment. Okay, so we've got to be pretty careful around that one because this is pretty specific. Okay, a risk assessment and the socket is not being used by an ordinary person. Okay, so that ordinary person, there's a note on the bottom there, for the purpose of this exception, an ordinary person, BA1, instructed in the use of the installation does not become an instructed person electrically. Okay, there's a couple of examples I can think of where we might be able to use this. So if we've got a plant room in a high-rise block of flats or something like that, we may have a socket underneath maybe a TPN board that is for supplying equipment in that plant room. That plant room will have restricted access, okay? It will be a locked door, and the only people going into that room, hopefully, will be electrically qualified people, okay? So we've got to be very, very careful how we apply this risk assessment, but we can do it if we really need to. Okay, next part 4, arc fault detection devices. So this is where one of the biggest changes has happened. So 18th edition, AFDDs were recommended for all final circuits, recommendation only. Okay, they've gone away, they've looked at this regulation and they've come back with this one. Arc fault detection devices, okay, shall be provided, so it's the word shall, so we must do this, for a single phase AC final circuit supplying socket outlets with a rated current not exceeding 32 amps. And then he gives us this 4 categories of building. This is important, okay? Higher risk residential buildings, houses in multiple occupation, purpose-built student accommodation and care homes. They've taken 4 categories of building that are difficult to evacuate in the event of a fire. And we've got a note now for high risk residential buildings. Assumed to be a residential building, over 18 meters in height or in excess of 6 stories, whichever is met first. We now get some HMO, 3 or more unrelated persons living in a property, okay, sharing shared facilities. Care home, okay, very difficult to evacuate people from a care home that are bedbound. And then we get purpose-built student accommodation. We all know that students are pretty much prepared to plug anything into a wall socket, okay? That could be phone charging equipment, it could be cooking equipment, it could be heaters, it could be fans, okay? Those are the things that can cause us a problem if they're not maintained and looked after. So that's where they've selected these categories of building. Now what they're saying is for all other premises, the use of AFDDs, okay, is recommended, okay? So just remember the weighting behind that word recommended. For single phase AC final circuits supplying socket outlets not exceeding 32 amps. So where used, the arc fault detection device shall be placed at the origin of the circuit to be protected. Okay, we've got to have 1 per circuit, not 1 per board. The next thing we jump into is surge protection. This is another big area that's changed for us. Okay, they've completely rewritten surge protection regulation. The risk assessment that we used to have to do has been totally deleted. Okay, so we've got rid of that risk assessment. So the regulation now says protection against transient overvoltages shall be provided where the consequence caused by the overvoltage could result in. Now they've changed this. We used to have 4 categories. We now only got 3. Okay, so first one, serious injury to or loss of human life. That hasn't changed. Okay, so we could equate that to doctor's surgery, intensive care unit, somewhere where if the equipment became damaged, we could have this loss of human life. Okay. Number 2, this is a new indent. So failure of a safety service. Okay, what is a safety service? Could be a fire alarm system, could be a sprinkler system, could be emergency lighting, it could be a smoke detector. Okay. And number 3, significant financial or data loss. This is retained from the old regulation. So significant financial loss, okay, that could be a manufacturing plant, the machinery gets damaged, they can no longer produce something, all of a sudden they're losing money because they can't produce a certain product. Data loss could be a data center for a bank or somewhere like that. If their servers got damaged, again, they're going to lose this data. Okay, so it's important we look after these types of property. So for all other cases, okay, protection against transient overvoltage shall be provided unless the owner of the installation declares it is not required due to any loss or damage being tolerable, and they accept the risk of damage to equipment and any consequential loss. Okay, so that's a bit of a get-out clause for us. We can only use that if we don't fall into one of the 3 categories above. Now, we mentioned failure of a safety service. Okay, so we take a domestic dwelling, we take a smoke detector. Okay, it's a wired-in smoke detector to a consumer unit. We fall into that bracket of number 2. So a domestic property, if it's got a wired-in smoke detector, we have to fit surge protection. Okay. Right, part 5 now. Okay. This is a little bit easier to get your head around, really. Okay, so we install a board. We work quite hard to make sure that the installation of that board is neat. Okay, it's tidy. Okay, then we put the front cover on it and we put stickers all over it. Okay, now most domestic properties, these boards are going in a more prominent position than they've ever been before. So they aren't being hidden away in cupboards under stairs and things like that anymore. Do we really want this information on show like this? It does make the board look untidy. We are now allowed to put this information into a pack and give it to the homeowner. We don't have to put these stickers on the front of these consumer units anymore, with one exception. Where we have a solar generator on the roof, okay, we have to warn somebody that when they turn this board into the off position, okay, that there may be a secondary supply into this board. Okay, we need to turn off all the supplies into this board. So that's the only sticker we need to put on, but it is only when we've got a second form of generation into that board. So small change to the color of a functional earth conductor. Okay, what's that? So when we got an RCBO, we get a functional earth conductor. We've actually taken all those functional earth conductors off our devices now, okay? But there will be manufacturers out there who still produce an RCBO with a functional earth conductor. They're going to change color. Why are we doing that? It's to fall in line with European regulations. So Senilec, I mentioned them at the beginning, okay? This is just a simple color change to fall in line with them. There is also now no requirement to put a label on that says this installation uses 2 sets of colored conductors. Okay, we've been using these different colored conductors for a good amount of time now. We should all know what they represent. So where we were using red and black, okay, we've now been using brown and blue. We understand that. Okay, we know what that's about, so we don't have to put this warning label on anymore. Okay, RCDs. Okay, so these sort of RCDs turned RCD selection on its head a couple of years ago. So type AC RCDs, not used very often now, but you will come across installations where they are still installed. So it says type AC RCDs shall only be used to serve fixed equipment where it is known that the load contains no DC components. Okay, that's quite difficult really, because I mean they gave us a couple of examples here. They've put electric heating appliances, but if you put a timer on that heating appliance, we've got DC components in that timer. Okay, simple filament lighting. Okay, but if we've got electronic transformers or dimmer control, again, that's out the window. Okay, so we've got to use a type A RCD now, okay, for most installations. All right, now, luckily, as a manufacturer, we've taken the decision not to make a type AC any longer. We don't need one. A type A does everything a type AC does, and we can obviously still use that in installations. Now, unwanted tripping. Okay, this was discussed in the 18th. Okay, and what we basically said was we want to ensure that we do not preload a split load board with 2 RCDs in by more than 30% of standing earth leakage. We're trying to rule out nuisance tripping. Okay, it's still a consideration. It's still something we must think about. Okay, people still use split load boards. They are migrating slightly towards a main switch in RCBOs. And this is what they're saying now. Additional solution would be to consider the use of RCBOs for individual circuit protection. Okay, 9 milliamps is not a lot of earth leakage, and that's your 30%. So BS7288 socket, RCDs. So we've got a socket with an integral RCD built in. Never had a mention in the regs book before. Okay, they weren't considered as additional protection. They do get a mention now. Okay, so where we're trying to adhere to this unwanted tripping 30% rule, we could possibly use those in an office. Okay, where we've got a lot of computer equipment. We could possibly make sure that the wiring was of such a nature that we didn't need to protect the wiring with an RCD. But we could put the socket outlets onto these now socket RCDs. So each individual station, okay, would then have its own sort of socket outlet, RCD protection. Computer equipment has a lot of earth leakage. Okay, so it might be a way of getting rid of that nuisance tripping on large areas. Okay, guidance on isolation and switching devices. There's a handy table in the regs book. Okay, and it tells us what devices can be used for isolation, what devices can be used for just switching. Okay, so functional switching, emergency switching, and isolation. It's quite a good table, really. Okay. Okay, chapter 54, earthing. Okay, installation of equipment having high protective conductor currents. What do? We've always wired sockets where we've got this kind of circuit, where we use the 2 earthing conductors on the back of a socket. Now, that's great, but there were certain manufacturers that only gave 1 earthing point on the back of the socket. That sort of excluded them from being used in this situation. They've now said, we don't have that requirement anymore. We are allowed to use 1 earth terminal on the back of a socket. But in the board, we've still got to stagger our earths where we've got this high protective conductor current. We still have to put a label inside the board to say that's what we've done. Okay, so just be aware of that. You can use the sockets now with a single point, but in the board, you would still split up your earthing arrangement. Okay, this one is a new regulation, okay, a new requirement. So a generating set operating in parallel. We've had them for a long time. Okay, we've had PV installations, okay, feeding into a board for 20 years. But we've actually now just looked at it and said, well, okay, we need to now meet this new regulation where it says INA is greater than or equal to IN plus IG. So what does that really mean? INA is the rated current of the assembly. So where we've got this assembly, okay, so this consumer unit with all the products in it here, that's an assembly. And we give that a rating, okay? That usually has a rating of 100 amps, okay? We've then got IN, is the rated current of the incoming protective device. And it's got IE 100 amps. So there's our incoming protective device, the service cutout. That could be 63, it could be 80, or it could be 100. So we generally take it at its worst case, it's 100. Now, this is the new bit where we've got to factor in IG. So IG is the rated current of the generating set. Most PV installations will generate about 16 amps. All of a sudden, we've realized that these boards are being given the option of 116 amps, but most of them are only rated to 100 amps. Okay, that could cause us a problem. There's a few ways around this. We can either put a limiting device in here, okay, so a double pole MCB instead of a main switch rated at 100 amps. We can limit the amount of current that goes through this board, or we can feed this 16 amps into the board in a different way, okay. If we put that 16 amps into the end of the board here, okay, through an MCB, we're not actually putting 116 amps through the main switch and the RCBOs and the RCDs. Okay, so there's a few ways of doing this. It's something you've got to be aware of, really. We've got solutions for you. Okay, so if you come across a new installation or an installation where you're going to upgrade a board and they've got solar, okay, speak to us. Okay, we'll give you a solution. Okay, and it's all about making sure this board stays safe with the amount of current that you are offering to this board. Okay, very, very easy to over sort of egg this board basically and have more current going through it than we really want. Part 5. Okay, some devices can't be fed backwards. Okay, what does that mean to us? Okay, so when we've got an RCBO, it sits on a DIN rail and we feed the power into the bottom of it where it says line in. Okay, that would generally be a bus bar. Okay, neutral flying lead, that's fixed. Okay, so that goes into our neutral connector. And then we take our load out of the top here. Okay, where we're using these and we've got a PV system, we actually feed them backwards. Now we can't do that with an RCBO because what happens to it, we feed current through it the wrong way, it destroys this device. We've got to be very careful about that. So there's a few options. First of all, the things we can't do. Okay, so we can't feed backwards into an RCBO and we can't feed backwards into an AFDD device. Okay, but we can feed backwards through an MCB. MCBs are pretty much bulletproof. Okay, there's nothing really in there to get damaged apart from a bimetallic strip. So we can feed those backwards with current, not a problem. We do a double pole RCBO, okay, which is double mod. We could feed that backwards, not a problem. So we've got some solutions there now where we need to feed solar into a board, okay, other than the main incoming device, okay. Inspection and testing. Okay, so 643.3, insulation resistance. And we say here, where equipment likely to influence the result or be damaged, the test shall be applied prior to connection of such equipment. Okay, what equipment are we talking about? We're talking about LED drivers. We're talking about USB sockets. Okay, these can have a detrimental effect on our results. Okay, because we've got transformers connected, we've got electronic devices. We might get some very strange readings there, and sometimes putting 500 volts through these devices could damage them as well. So we do the test at 500 volts before they're connected. Following their connection, we're going to test at 250 volts, okay? And we're going to look for a minimum IR value of 1 megohm, okay? Manufacturer's instructions, it's always good to read these, okay? We test our equipment for the 500 volts. Most of our equipment, we can put 500 volts through it without damaging it. There will be the odd item where we can't. It will always be written in the manufacturer's instructions, the voltage that you can put through these devices when you're doing your installation resistance test. RCD testing. Okay, as I mentioned earlier, 2 years ago, RCDs were thrown on their head when we brought out all these other devices. Okay, so we've got type AC was the standard. We've got type A, we've got type F, we've got type B. Testing totally changed. Okay, we were looking at testing all these devices depending on what they were, okay, their type, okay. It made people go out and buy new test equipment, their old test equipment possibly didn't have the settings they needed. One of the things they did realize though is that while we're using these devices, they are always sitting on an AC waveform, and that's where they mainly get used. Okay, they may be immune to DC faults blinding them, okay, but they still sit on an AC waveform, and that is where we want them to operate. So they've decided for certification requirements now, we only have to perform one test. So it's a 1 times test, okay, using the AC waveform, okay, at its rated current, basically. So a general non-delayed RCD, we need that to trip within 30 milliseconds. Okay, that would be for a 30 milliamp device. Okay, an S or delayed type, we're looking for that to go within 130 milliseconds and 500 milliseconds. Okay, so testing has become quite a lot simpler on RCDs, certainly for certification purposes. Right, part 7. Now we're getting towards the back of the regulations. All right, so there's been some changes to most of the special locations. 701. Now, this is a little change, really. So from the edge of zone 1, we have reduced the distance that we can have a socket from 3 meters down to 2.5. We're slowly falling in line with Europe. Okay, in Europe, if you go on holiday, you'll see that there's usually a socket in a bathroom. 711. Okay, selectivity between RCDs. Now, it used to say selectivity between RCDs where necessary. It now says shall be provided. Okay, solar PV. Okay, 712 has been completely rewritten. There's a lot of work gone into that one. 714, outside lighting installations. The addition of additional protection by RCD required for any area open to the public. Okay, so public car park, okay, with outside lighting, we now have to have additional protection via 30 milliamp RCD. Electric vehicle charging. Okay, from now on, if you want to fit a vehicle charger to a split load board, we can't use the 2 RCDs that are in there. Okay, we have to supply that vehicle charger from its own RCD. Okay, if there's a problem with that charger, we don't want to cause a problem for the rest of the installation by putting off numerous circuits. Okay. Part 8, energy efficiency. Okay, that's been sitting in the wings for a while. So anybody that produces electricity as well as consumes it is now called a prosumer. So anybody with solar panels, okay, battery storage, okay, we've got a few options here now. So if we have a look at this diagram, we've got item number 1, that is our grid supply. Item number 2, solar panels on the roof. Okay. Number 3 is our distribution board. Number 4 is our battery storage, backwards and forwards there. For instance, if the sun is out, okay, we're producing electricity on these solar panels. The batteries could be fully charged. Do we really need this grid supply? Possibly not. We could put this installation into what they call island mode. Okay, we can do that, but what's it say here? It says functional and safety requirements have got to be adhered to. So we've got to ensure that if we do put this installation here into island mode, when we disconnect from the grid, we don't disconnect from any of the earthing arrangements that we need for this installation. Okay, that's very, very important. Okay, documentation changes now. So we used to have 3 pages of tick boxes, okay, on our certificate. They've reduced that down to 14 boxes, okay. So that'll speed things up a little bit when you're doing an inspection. So we used to have, under section number 1, we used to have 3 or 4 boxes. Now we've just got the 1 box under section 1, okay. So we're ticking for the whole thing now. We're not broken up into individual sections. Harmonized core colors. Okay, so we're looking at appendices there. Okay, so harmonized core colors, they've been deleted, been taken out of the book. Appendix 11 was previously not used. Okay, So we've put in there now warning and instruction labels. Okay, they've moved into that appendix. Appendix number 13. Okay, so it gives us, I don't know why we've done that. Appendix number 13. It's given us a method of measuring impedance of floors and walls for non-conducting locations. And it mentions escape routes and fire protection. But that also could include hospital operating theatres. It could incorporate electronic labs where we want a non-conducting covering on the floor and walls. Okay, so that gives us the method for measuring this in these areas. So it's always worth a read in these areas. And that's pretty much it, ladies and gentlemen. I think we've pretty much got through the Amendment 2 regulations that really apply to you. I will take a few questions if there are any, and then any other questions that we don't answer, we can publish on the website. So thank you very much for joining us this lunchtime today. I hope it's been of some interest to you, and thank you.
Thank you, Ian, for this insightful presentation. We have a couple of questions that we can take now, and the rest we can follow up with them by email. Okay. So first question from Steve, whilst carrying out an EICR, what fault code would you use for a consumer unit with no SPD or a consumer unit with no AFDD on our RCBO protected socket circuit? Would you need to install new RCBOs or SPDs?
Okay, so the one thing that you need to remember with the regulations is that we can't apply these regulations retrospectively. So when an installation was installed, it was installed to a past set of regulations. So that's great. And as long as the installation is still safe, we don't have to worry about the new Amendment 2. But when we're doing an EICR, and you're quite right to point this out, it would be worthwhile coding that as this installation falls into a certain category, and under the new regulations, it would require different kinds of protection. We could possibly code that as a C3, so that in future use, okay, that would need looking at going forward. It's something we should think about moving forward. But that's all you would code it as, is a C3. Okay, hope that answers your question.
Thank you, Ian. Another question's from Pete. If example, installing a new mini CCU for shower, does it have to be SPD? Does it have to have SPD?
Okay, now the good thing about that one is that when you're installing a miniature consumer unit, possibly just for a shower, it is still connected to the rest of the installation in that property. So although it's separate, it would be connected at source. So therefore, I would say yes, it would need a surge protection device if there is a safety service wired into the consumer unit in that property. Because although it may seem that it's in a separate consumer unit, okay, when that surge comes into the property, okay, that surge is pretty indiscriminate and will pretty much go anywhere. So if we can null that, okay, and your new installation of a consumer unit would need you to meet the Amendment 2 regulations. So I would say yes, you would need to put a surge protection device in there if there is a wired-in safety service in the property.
Thank you, Ian. Maybe we can have one more from Daniel.
Yeah.
Are there any tests done on AFDDs with LSOH cabling?
Okay, that's an interesting one. Now this question comes up quite a lot. So LSF cable is designed so that it does not carbonize. Now an arc fault detection device is there to detect carbonization, heat and arc faults. So because LSF cable doesn't carbonize, we don't get the arcs that we would get in a normal PVC cable. That's great, but because AFDD is recommended for socket circuits, and they also protect from the socket to the appliance. Every appliance we buy today comes with a PVC cable, okay? So the internal wiring Okay, if you could guarantee the internal wiring on a property was wired with an LSF cable, that's great. But from the socket outlet to the appliance, we are also protecting that cable. And that is the cable that can get damaged. It can get damaged by getting trapped under doors. It can get damaged by getting caught against things. There is a very, very high likelihood that that cable to an appliance could be the cause of a fire. And that, again, is what we are looking to protect. So until things change where every appliance comes with an LSF cable, then you would still need to fit an arc fault detection device. Although LSF cable is a good way of getting away from the issue of possibly having a fire or an arc, okay, the things that we plug into sockets, we have to protect as well. I hope that answers your question.
Thank you so much, Ian. We have a few more questions, but we will follow up by email. Thank you so much, guys, for the really great questions and for joining us today. If you have any more questions or any thoughts, you can always email us at marketing@rexel.co.uk. And as I mentioned earlier, your certificates from CPD will be received hopefully within a month. And yeah, we are looking forward to have you in our future webinars. Thank you so much, Ian, for this presentation, for being with us today. And have a great weekend, everyone.
Thank you very much, everyone. Thank you.